Uh, Good evening, Doctor. My name is Sechazi Ovis. On behalf of Group 1 with my colleague Matsaka Emerson. Mm, Yeah. Our title is Photo Voicing Accelerated Educational Content Generation Using Large Vision Models. Basically, photo voicing basically means a creation of a series of images to describe maybe a given scenario, and accelerated educational content generation, like creating basically learning materials at a fast way using large vision models. And basically large vision models, these are artificial intelligence tools that study visual data, basically images and videos, so as to create different scenarios. So for our title, photo voicing accelerated education content using large vision models, basically is defined by using artificial intelligence materials like large vision models such as GPT-4 to create educational content at a very large speed through studying a series of visual data like images, videos, among others. So, mm, basically this is the content on which our presentation is about. So the background, basically Uganda is among the most countries infested with refugees, according to the UNHRC. And Uganda hosts a number of up to 1.4 million refugees. And basically, our view is for the photo voicing AI solution. Basically, is due to the limited or lack of the educational content in the refugee settlements. Basically, these refugees, most of them come from where they maybe their former settlements, when they were basically on another curriculum, or when some of them are not at a level at which, or when are not under the same curriculum. Basically, and these people are given little time to cover a lot of content, and basically they are fed with a lot of theoretical content that is even irrelevant from their cultures, basically, which in the long run, they are unable to get more knowledge in a given time. So we are a review of the photo voicing educational content generator that will use, as you see, photo voicing will use visual data or visual images to create a series of scenarios about a certain topic that those students and educators are able to use to get more knowledge about the given topic to study, so as to meet their curriculum goals. This basically it is gonna be culturally relevant. The final product will be culturally relevant to their culture, basically culturally relevant, since these refugees are from different cultures. It takes them more time to learn things in the culture in which these curriculum are made. Basically, the curriculum is basically made of the Western civilization or the Western ways of studying, and it takes time for the refugees to cope with what they are supposed to cover in time, due to the fact that they require more time to first understand the concepts from the Western norms. Basically, let's say about farming, the tools that are used by the curriculum basically are from from the Western states, like if they are teaching about farming, you will find out that they are using uh, these excavators to plow the land. Yet, basically, in the normal settings of the refugee settlements, they have these local holes, which in this, it takes time for them to cover up the content. So the snapshot there is a prototype of the system that is available so far, an AI-powered photo voicing platform, and it transfers curriculum topics and generates narrated visual stories for refugee learners, uh, culturally multilingual, and it accelerates comprehension, and it also bridges literacy gaps in Uganda refugee settlements. So, uh, basically, our literature review, we've covered numerous number of papers and with different models that are able to mimic how to do different number of things. An example is we've used multimodals. We've seen multimodals, and the recent advances in the multimodal AI provide critical foundations for our work. Basically, was the Lava and the Pali. These are robust visual instruction following These have robust visual instruction following capabilities, enabling complex image text explaining. Then we have the story Lava. This introduces topic-driven narrative organizers for coherent visual storytelling. And basically, ControlNet and UniControlNet, this offer precise spatial control over diffusion models are essential for cultural authenticity. Basically, the ControlNet and the UniControlNet help these diffusion models. The diffusion models are these models that are able to create images. So ControlNet and UniControlNet help to define the shapes, the sizing, and the corners, basically how the image should look. Then we have the mobile VLM. This proves efficient vision language deployment on resource-constrained devices. Basically, mobile VLM will aid us in compiling or deploying the model on mobile devices, and concurrently research in humanitarian education highlights the efficacy of visual localized content in refugee settings. And basically, the system integrates these technical advances within an education-specific framework, which adds curriculum alignment, cultural validation loops, and offline deployment for low-resource environments, which in turn addresses the gap between generative AI capabilities. So the problem statement, the domain specific. Basically, Uganda's refugee settlements lack engaging, culturally relevant content, competence-based curriculum aligned learning materials due to the low resource settings in such areas. Classrooms are overcrowded. There are many refugees who want to learn the text, the books. Okay, the text they use are heavy and are not complying to their maybe the languages. So these learners are traumatized, and it hinders them in grasping concepts in the accelerated education programs, goal of foundational literacy and numeracy, deepening the educational quality for such refugees. Basically, the computational problem we have is uh, we have to generate a coherent culturally accurate visual narrative from educational prompts, and this requires using a number of models that are able to understand images, characters, audio, among others. So, uh, 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 research questions are basically we aim to design, one of the objectives, we aim to design and implement an offline fast photo voicing content generation framework. This means the final product might still be able to work offline, since our case study is those low-resource areas where refugee settlements are. Most of them, it's limited internet connection and the network is unstable. So we need to implement an offline first device to implement it to be able to work on those offline devices. So the other is to develop complete competence-based curriculum and learning models using the large vision-based image generation here. So using the available competence-based curriculum by the NCDC, we shall be able to train the models through text to image, and they will be able to generate, shall be able to deploy a model that is able to create content that aligns with the competence-based curriculum. So the other is to integrate generative storyboard engine for automated visual sequencing that will be able to create a sequence of visual images to explain a different scenario. For example, you come from a scenario where maybe a farmer, how if the steps through which a farmer goes in to come up with a maize plant, such a scenario can be able, can the model can be able to create a scenario in which in the steps in which the maize goes up to maybe harvesting. The other is to optimize rendering and deployment to low power offline environments, as I talked earlier. Offline fast photo voicing content generator. Research. Basically, we developed the first offline fast AI pipeline for generating culturally relevant education content in refugee settings, and we built a novel a two-phase architecture that combines cloud-based authoring with non-learning devices, and we deployed a complete photo voicing system that transforms curriculum topics into narrative visual stories that demonstrates measurable improvements in learner engagement and comprehension with Uganda settlement schools. So this is the methodology or the architecture, and it is of two phases: the cloud-based authoring and the phase two, the online device learning. Basically, the teacher will input a topic. So one, how to grow maize, and basically a high performance model such as Lava will be able to break the topic into 3 subtopics. And in those subtopics, we have a visual generator or a model that generates visual images. That one we shall say stable diffusion. Will generate images according to those 2 topics. That's we shall say step 1 will generate an image maybe of soil, and step 2 will generate an image of a farmer digging. Step 3 will generate an image of maybe a maize plant. So the TTS engine generates the narration, and that narration will be in the form of those image series into an asset bundle. The second phase on device, basically a mobile device, will have a unit app that plays the story where a student will ask question and a mobile optimized model provides localized answer. So with the description of our data set, basically, we also carried out data analysis. And for our data set, it has the data set basically we created it ourselves, since we are wanting it to be in the content we want it to be in line with our culturally relevant settings, to be culturally relevant to our local settings, basically the refugee settlements we know. So the data set we created a simple data set of 165 comprehensive biology entries from senior 1 to senior 4 curriculum, and 100% data completeness with 98.18 unique narration scripts that include quizzes, animations, and touch interactions, and 54% culturally approved content optimized for low resource deployment. Basically, completeness, it's 100% and it is 98.1 unique since the dataset we created it ourselves. We believe it is 98% unique. The cognitive score basically is 2.4 and the storage 10.103 MBs. So we also carried out data analysis, and basically, as you see, we have the biology S1, then up to S4. We have the topics such as Introduction to Biology and Senior 1. We also created, we are able to create a narration script from the data set. Basically, based on the comprehensive experiment result, a proposed photovoicing system demonstrates significant improvements. This is basically the output results and discussions, and the integration of the unit control net, which was with the fine-tuned stable diffusion, and it achieved 91% accuracy, 91%, 0.5% accuracy for culturally relevant deprecation. For culturally relevant deprecation. Basically, the quantized low rank adapter, what adapted the lava model, maintained 98.7% of the full time tuning performance, and the clip-based validation system successfully filtered semantically misaligned content with 92.3 precision. And that we were helped by the fact that we created the data set, our own. So things of accuracy, we were good to go with that. So the explainable AI results are basically, we have TTS system comparison performance metrics, WaveNet XTTS V2. So we have Google WaveNet, which is high fidelity but culturally generic and requires internet making. It is suitable for offline humanitarian context. So the explainable AI system integration for the two-phase architecture, we have cloud authoring, that is on-device learning architecture and is a master stroke of explainable system design for constrained environments. The models we selected are Lava 7B for instruction decomposition, unit control net for culturally constant images, the mobile VLM for on-device Q&A, Crawler quantized low rank adapter for efficiency, which is 80 GB to 20 GB for fine-tuning, clip validation for sign similarity, and then the inference time was 4.1, and the model size was 500 MB for Raspberry Pi deployment. That is a snapshot of the deployed model and how it works, and this is a pipeline, the cloud-based authoring platform of the pipeline is also of two phases and the on-device learning experience. The first phase, as the teacher enters the topic, it is broken down into 3 subtopics in which those subtopics are a model called Stable Diffusion can create images for the 3 subtopics, and then the images are assembled into a narrative visual story. The motivation of the developed project. Then our AI transforms teacher topics to narrative visual stories, and it input out to grow maze and receive step-by-step illustration, illustrated instructions with synchronized local language audio. This photo voicing approach accelerates comprehension for refugee learners working entirely on offline low-cost tablets. And our IP portfolio includes patented photo voicing architecture for educational content generation, proprietary Ugandan content-based curriculum, aligned training datasets, and the unique two-phase cloud edge deployment model. And here we hold the copyright on all AI-generated curriculum assets, basically, and trademarks on the system's branding. These protected assets create significant barriers to replication while enabling scalable humanitarian deployment through licensed partnerships with NGOs and governments. So, conclusions, our system successfully generates culturally relevant educational content for refugee learners, demonstrating improved engagement and comprehension. And however, limitations include dependence on initial curriculum quality, limited device compatibility, and ongoing needs for cultural validation. And sustainable impact requires continuous teacher training and infrastructure support in settlement schools. The solutions, limitations and solution basically, it is dependent on device and it requires Android tablets or Raspberry Pi. And the solution here, you have to partner with hardware donors for bundled deployments. Then the content scope, let's calculate biology only, and later we shall expand to the full CBC curriculum with the NDCD collaboration. The power resilience needs electricity, and solution integrates solar charging stations in settlements, and teacher training requires digital literacy. And here we are to develop a train those teachers. Future works, basically, our immediate priority is expanding content coverage beyond biology to include literacy, numeracy, and life skills. Basically, those are the acknowledgements. And so, with all that, I request to end my presentation. So,